Okay, in this video we are going to start talking about making a confidence interval, especially when we know our population standard deviation. Okay, so we're going to get started here. So it talks about using a sample data information, and then we're going to estimate what the population would look like based off of that. Okay, a point estimate is a single number used to estimate a population. Okay, in this section, our point estimate is going to be a mean. Okay, all right, the best point estimate is one that is unbiased and comes from good data. Okay, a confidence interval, this is a range of numbers used to estimate a population. Okay, it can look like an inequality or an interval. So, for example, get set up here. If I think that a population mean is around 10, I could say that the population mean is between 9 and 11, okay, like an inequality where that population mean is between those numbers. Or I could use what's called an open interval and say 9 to 11, something like that, okay. This is an estimate. We can't be totally certain that something contains a parameter, but we can be what's called confident. Okay, so this level of confidence is the probability an interval contains a true point estimate. Okay, so we're not just going to say we're a little bit confident. In math and statistics, we're going to assign a number to that level of confidence, this C. Okay, so C is our level of confidence. Basically, this is an interval associated with a specific level of confidence. Okay, margin of error, this is the maximum error of estimate. Okay, so our confidence interval and margin of error are very closely related. Okay, as our confidence, let me do this, as our level of C increases, okay, as the level of confidence it goes up, the margin of error will also kind of change with that. And we'll see that in a problem below. Okay, so these two things are related together. Okay, so to construct a confidence interval, we're going to add and subtract the margin of error from the point estimate. So that will look like this actually. And I didn't really leave a lot of room. So we'll have a sample mean, and we'll subtract the margin of error. And we'll have a sample mean, and we'll add the margin of error. And we're going to say that our population mean would be in between those two things. Okay. In order for this math to work, we need a simple random sample. We need to know the population standard deviation, and we need a sample size of at least 30. Okay. All right, so let's look here. It says a college student researching study habits collects data from a random sample of 250 college students. All right, so we have a big sample size here. We have a sample mean of 15.7, so that's telling me X bar is 15.7. All right, the margin of error for her data using a 95% level of confidence, so it's giving us E and a specific level of confidence. Okay, so we want to construct this interval. So we're going to do our sample mean minus the margin of error and our sample mean plus the margin of error. And we're just going to plug in the numbers here. So So I have 15.7 minus 0.6 and 15.7 plus 0.6. So I'm going to subtract these two things and say 15.1, and then add these two things and say 16.3, and there's my confidence interval. I could also write it as 15.1 and 16.3 without the inequality symbol. Okay. All right, so now our level of confidence is going to increase. I'm going to be 98%, and my margin of error also increases when this happens, now to 0.08. Okay, so if I want to be 98% confident, I'm going to have a bigger range of numbers here. So now I'm going to subtract 0.08, and I'm going to add 0.08. Okay, so now at 95% confident, I can say that my population mean would be between 14.9 and 16.5. Okay, so if my range goes up, I can be more confident that the population mean is between those numbers. Okay, if we widen the range, that increases the confidence. Okay. So, like I said, that level of confidence is not just a random number, okay? It comes from our bell curve, okay? And I'm going to be 95% confident in this picture that my population mean is in a certain range, okay? So that's what this picture says. And then, of course, our level of confidence could change, and it would slightly adjust this picture, all right? But a level of confidence is the probability a population mean is in our interval. Okay. All right, so C represents this area that's shaded in the blue. Okay. Now our level of significance is this alpha symbol. Okay. And the level of significance are these two tails. Okay. So 1 will equal whatever our level of confidence is plus our level of significance. Okay, I could also say this level of confidence is 1 minus my level of significance. Okay, if I take this total area, and divide by 2, what you see right here, it will give me the area in one tail. Okay, well, this area in one tail is going to be associated with a specific z-score. So instead of using our big standard distribution table, what we have here is like a little shortcut for z-scores that are going to be associated with a level of confidence. Okay, so for the problems in this section, we won't have to go use our big table. We can use this short table here where they've got your level of confidences already listed out and the z-scores that go along with them. Okay, this notation at the end is just saying that basically we've found, this specific z-score for this problem. Okay, so we will use these critical z-score or z-values and using this table here. There's a formula for the margin of error. All right, and those previous problems it was given to us, that won't always be the case. So the formula for the margin of error, all right, we're going to take that critical z-score from the table right here, okay, from this table, and we're going to multiply by the population standard deviation over the square root of our sample size. Okay. Once we know that margin of error, then we can find our confidence interval. All right, so let's do an example here. Okay. In order to estimate the number of calls to expect at a new suicide hotline, volunteers contact a random sample of 35 similar hotlines across the nation and find that the sample mean is 42.0 calls per month. Construct a 95 90% confidence interval for the mean number of calls per month. Assume that the population standard deviation is known to be 6.5 calls per month. All right, so we've gathered this data from this word problem. Find the point estimate. The point estimate right now is our sample mean, which is 42. All right, find the margin of error. So I'm going to use that formula we have above. Now, here's the deal with that. This formula requires me to have a specific z-score. To find that z-score, I need to look at my level of confidence. My level of confidence is 0.95. So what I'm going to do is I'm going to go to my table. Here's my level of confidence, 0.95. There's my alpha, my level of significance. My z-score for this is going to be 1.96. So now I'm going to come back here and in my formula put 1.96, and then I multiply by my population standard deviation over the square root of n. All right, so I'm going to put this in my calculator all in one step. Okay, and actually, let me do this. Okay, so here's my calculator. I'm putting it all in one step. All right, so we're going to have 1.96 times, and then in parentheses, I'm going to put 6.5 divided by the square root of 35. Some of us are putting too much stuff in our calculator, or you're rounding your decimals too much, not putting it in right. Okay, so I wanted to make sure I included that. I'm going to hit enter, and whoops, I didn't want to do that. Get our answer here. All right, so when we do that, we should get 2.15345. Okay, some of us are rounding our decimals too early in our work, and it's causing us to get the wrong final answer. Okay. All right, so now I'm going to add and subtract this to our point estimate. So I'm going to do my 42 minus 2.15, and now I'm going to say 3, and 42 plus 2.153. Okay, and so my final answer here is going to be 39.85 and 44.15. Okay. All right, so next problem. When you measure 25 watermelons and find they have a mean weight of 53 ounces. Assume the population standard deviation is 12.5 ounces. Based on this, what is the maximum margin of error associated with a 90% confidence interval? For the true population mean watermelon weight, give your answer as a decimal to 2 places. Okay, so this one's just asking us for the margin of error. Okay, but to find that margin of error, I still need that z-score. So my level of confidence is 0.90. All right, so I'm going to go up to that table. And now I'm looking for 0.90, so my z-score is 1.645. That gets multiplied by my population standard deviation over the square root of n. I'm going to put this in my calculator all in one step. 1.645 times 12.5 divided by the square root of 25, and I get 4.1125. Now it says round to 2 decimal places, so I'm going to keep that 4.11. All right, next question is multiple choice. You're going to see some of these in your homework, and it's basically just interpreting this data. All right, so it says 95% confidence interval. We have a sample size of 98. Which of the following is a correct interpretation of the interval So this right here. So we are 95 or 98% confident that our population mean is between these two numbers here. That's what that means. So let's see. The mean width of all widgets is between 12.1 and 18.9, 98% of the time. No. There is a 98% chance that the mean is between that? No. With 98% confidence, the mean width of all widgets is between 12.1 and 18.9. I like that because of all widgets is talking about our population mean. With 98% confidence, the mean width of a randomly selected widget will be, no. There is a 98% chance, no. Our answer is C. A professor wants to estimate how many hours per week her students study. A simple random sample of 78 students has a mean of 15 hours per week. Construct and interpret a 90% confidence interval for the mean number of hours students study per week. Assume that the population standard deviation is known to be 2.3. Okay, so our margin of error, I need my Z score for 0.90. All right, so I'm going back to that table. It's 1.645. That gets multiplied by my population standard deviation over the square root of n. I'm going to put that all in my calculator in one big step. Let's see here. So that will give me 0.43. Okay. So now I'm going to take 15 and I'm going to subtract 0.43. And I'm going to take 15 and I'm going to add 0.43. All right, so my answer is going to be 14.57 to 15.43. All right, suppose the confidence interval. So now we've got the parentheses. This means the same thing as 0.6477 and inequalities 0.8352. Okay. Suppose the confidence interval represents the proportion of RCC students who say math is their favorite subject. Based on the confidence interval, is it likely that 55% of RCC students say math is their favorite subject? 55% is 0.55, and that is not within this interval. 0.55 is down here. So I'm going to say no, this is not likely. This is false. Based on the confidence interval, does it appear that more than 55% of RCC students say math is their favorite subject? Well, yes, because we're saying our population mean is bigger than the 0.55. Based on the confidence interval, does it appear that fewer than 55% of RCC students say math is their favorite subject? No. Okay, because fewer than would mean our population mean would be like less than 0.55, so the answer is no there. Okay, our last little formula for this section. Sometimes we have a study in mind we want to do, and we need to figure out what is the sample size that we need to make this study work, okay? So here's the formula to figure out the sample size you need. N is going to equal that critical Z value times your population standard deviation. All of that gets divided by your margin of error and raised to the second power. Now, when we do this, we're going to round all decimals up to the largest number. Okay, so even if I do this formula and I get something like 15.1, I'm going to round my answer up to 16. Okay. Same thing if I get 15.9, I would say my final answer is 16. We always round those up. Okay. All right, so this says determine the minimal sample size needed if we wish to be 90% confident that a sample mean is within 2 units of the population mean. Well, that means that our error is 2. An estimate for the population standard deviation is 8.4. Okay, so we are going to use this formula here. All right, if C is 0.90, then using the table, I can have my critical z-score is 1.645. All right, so N equals 1.645 times 8.4. That's going to be divided by 2 and raised to the second power. All right, so I'm going to do what's inside these parentheses first, and that gives me 6.909. And now I'm going to raise that to the second power, and I get 47.73. So I'm going to round up to 48 for my final answer. All right, that's it for this section.